So we're starting section 2.1 asking, is it a polynomial function? So my question to you is, what do you know about polynomial functions? What does a polynomial function mean to you? What is a polynomial? You know, it's a happy Monday to you guys. It's an expression. So a polynomial is an expression, and it has, I would say, it has variables. And those variables have exponents. I believe there are some constants, so there are some numbers up front, and then there are also, or constants numbers in the back, and there are also coefficients numbers up front. So just a combination of numbers and variables. Now this is different than a power function. So we've talked about a power function, which is just any function where x has an exponent. This time my exponent has to be kind of specific. So we're going to look at a couple examples. Is letter A polynomial function? Could I do 3x raised to the negative 15 plus 17? I see that some of us are like, yeah, we've got that little exponent. I'm going to argue, what does a negative exponent mean again? It's in the denominator, right? So that's like what, 3 over x to the 15th. Remember my BFF graph that has a fraction and x in the denominator? We cannot have that. That's actually a reciprocal function. So we're going to say this is not a polynomial function. Or I'll just say no. And instead it is a reciprocal function. Now that would be a power function like we talked about back in 2.1 or 2.2, but it's not going to be a polynomial function. Similarly with letter B, is that a polynomial function? If not, what function is it? So it's a square root, it's a radical one. So I've got this radical here. So it's instead, that's not a polynomial, it's a radical. And I'm not going to call it square root, just semantics, because I've got this to the 5th power on the radical. So it's not a square root, it's a 5th root. All right, what about letter C? Is that a polynomial function? Yeah, I'm going to say that one is, and it actually has a special name. What's the name of it when it's just x with no exponent? Call it linear, we call it identity. One of our BFF graphs. What about letter D? Is that a polynomial function? Also, yes. That also has a special name. Do we know what that special name is? Quadratic, squaring. You can call it, the shape is a parabola. And then last but not least, what about letter E? Is that a polynomial function? I'm going to say that one is yes. That's, I think, a quintessential polynomial function because it's got like this big exponent and it's just going to do kind of those curly-Q roller coaster rides as we graph it. We're not going to graph until later this week though, so. But again, good thing to know if we're dealing with polynomials, we do not want a negative exponent. We do not want a square root or a fraction exponent. So polynomials must be exponents. And I may even come up here and amend my first statement. I might say whole number exponents. It must be whole numbers. And I may even put positive in front to know that they can't be negative. They've got to be positive whole numbers. Okay. Moving on to number 2, we're going to do some linear functions. So this says write the equation of a linear function given. Remember, a linear function is in the form of what? Y equals mx plus b. Very good. Y equals mx plus b. So we've done that already. You might be like, we've already spent time doing this. I promise you it's very similar to what we've done, but notice that the setup is a little bit different. This time I give you the points in function notation, not as a coordinate point. So this is a function notation. F of 2 equals 3 and f of 4 equals 11. Okay, what there is your x? Which value there is your x value? 2. Normally it's written as f of x equals y. So that number in parentheses is my x, and that means that 3 is my y. So we can label those x1, y1, and we can label the other one, what's my x in f of 4 equals 11. 4 is your x, and what's your y? 11. So we've got x1, y1, x2, y2. This is the exact same problem as if I listed it 2, 3, and 4, 11. I just put it in function notation. Function notation. I'm not going to necessarily test you on that, but just so you know, that's what it's officially called, function notation. So I can give you a pair of ordered points, I guess, in function notation, and we can just use it just like we normally would. So we'll take those 2 points and we'll find our slope, and then we'll plug that into our point slope form. So reminder, if we're doing our slope, we're going to do y2 minus y1. I'll do 11 minus 3 over x2 minus x1, 4 minus 2. I get 8 over 2, so I get 4. All right, now I don't care how you find your slope intercept equation from here. I like to use point slope, so I'm going to continue using it. I'll do my y minus y1, and I don't care which point you use. I'll probably just use the first point. So I'll say y minus 3 equals m, or 4 times x minus 2. Just making sure my points are right. Yep. And then I just simplify from there. We did linear equations, point slope, slope intercept a lot slower before. So if you need to go back and review, or you need to come see me for office hours, great. But I'm going to assume that we should know how to kind of just roll right through these. So I get 4x minus 15. Cool. Can you do the one below that? Label your x1, y1, label your x2, y2, and we'll go from there. All right, I think I've got the answer for the next one on the board if you want to check that out. Is that what you guys got? So again, we're just doing linear stuff. We've already done that. We've already practiced that, but we were just practicing that again, just in a different form. Okay, now I think for the rest of today, we're going to focus on our quadratics. We're going to focus on our vertex, axis, symmetry, and direction of our quadratic equations. In the past, a lot of times we see quadratics in the form, like in standard form, ax squared plus bx plus c. That's my standard form. I want to do vertex form. Is vertex form a thing that you guys did back in algebra 2? Yeah, I'm going to pretend like you haven't looked at it for a while because I know that you haven't. But this is, again, I'll call that standard form. Vertex form is very similar, but it's already written in the way that you know what the vertex is. So vertex form is y equals a times x minus h squared plus k. This form is very helpful to us because my vertex is very easily visible in this form. Your vertex is h comma k. Notice that in the parentheses, it was minus h, and it's going to be a positive h when you take it out. So remember, we'd always do the opposite of what's inside the parentheses. And the k was positive outside because it was not in the parentheses, and it's positive when we carry it down. So h, you switch signs, k, you keep the same sign. We also know our axis of symmetry super easily right here. Our axis of symmetry, does anyone know what that is? Could you describe axis of symmetry to me? The line, where is that line at? Not at A, we're gonna look at just one of the letters there. That line is down the middle of your parabola, so if your parabola is here, that line, that axis of symmetry is right here, and it's gonna go through your vertex, and it's the same value as your X value right there. So your axis of symmetry is just X equals H. It's just the X value of your vertex. And then last but not least, our up and down depends on just what the A value is. If it's positive, then it's up, and if it's negative, it's down. So just looking at that A value is what is my direction. The reason I wanted to go through that slowly is because now you'll notice that we're going to take things that are already in vertex form, and we're going to identify the vertex, axis of symmetry, and direction. It's super easy when it's just written out directly in this form. Okay, so let's look here. Let's do vertex first. Bless you. What's my vertex here? Sorry, what was it? -1, -4. So you just look at your H and your K, switch signs of your H, keep the same sign as your K. That being said, what's my axis of symmetry? X equals -1. That H value that we've got there. And then last but not least, look at the very first number to decide whether it's going up or going down. Which direction is this one going in? It's going down. Negative. Very good. All right, let's look at the next one. What's my vertex for letter B? 3, what'd you say Y was? 0, very good. Jonathan could not be stumped. Because there's nothing being added or subtracted out there, if it makes you happy, you can literally write a 0 there to know that there's no number. So we didn't go up or down any, we literally stayed on 0. So we have to take our H that's inside, but we have nothing for our K, so we'll write 0. What's my axis of symmetry gonna be? X equals 3, very good. And then again, look at that number out front. Is it going up or down? Up, very good. Okay, one more just like this, same idea. What's my vertex? 3, 10. Sorry, what'd you say? 3, 10. What is 3 positive or negative? -3. Take it out. When you take it out, it switches. So -3 and then positive 10. I like that you have the 10 positive. What's my axis of symmetry? -3. And are we going up or down? Down. No, why did I say down? We're going up. You guys all let me write down like an idiot. Going up, positive up. Okay, we practiced doing 3 of those where they were already in vertex form. If you flip your paper over, we are now going to put them into vertex form. Okay, so if it's in vertex form, it's super easy to do. If it's not in vertex form, we got to do a little bit of work in order to get it into vertex form. I know that we've done this already, but we're going to review it again. In order to get it into vertex form, we need to do complete the square. We're going to complete the square. We practiced that back in chapter P, and if you notice here, I've got all sorts of numbers in front of my x squared. So we're going to have to deal with those factors, but we don't deal with them very first. We're going to deal with them in a second. I'm also going to go a little backwards. Let's do 3 first. I thought, or C, I think that's the easiest one. So let's jump down to letter C. We'll do that first, and then I'll work our way back up. Okay, so again, we want to get this into vertex form, and if you forget, vertex form is that y equals a times x minus h squared plus k. When we did when we did complete the square earlier in the year, we were solving for x, so we like finished the problem. I don't want us to finish the problem. I don't want x by itself. I want it to look like this form, okay? So we're gonna have to maybe team time out at a certain point. Instead of going too far, we're just gonna stop a little earlier than maybe we're used to. Okay. First things first is if you do not have if you have a constant, it needs to move to the other side. So if I have a plus or minus anything attached to the end, you need to move it to the other side. If you don't have anything there, that's fine. We're just gonna set this equal to 0. F of x is the same thing as just y, so you can get rid of that. Setting it equal to 0 lets us kind of manipulate this problem a little bit. And if you remember, I like to put blanks on both sides of my equation just because I know I'm going to plug something in there. Now, before I do my b divided by 2 squared, we do want to factor this left-hand side. So what number can I take out of both of those two terms? 3. I heard some of us say 3x, which you are totally correct on, but I want us to leave the x's in there because remember, we want to complete the square right here. We're going to complete this quadratic version by having a square as our last number. So we got to keep x squared, we got to keep x in. So we just take out a constant, we take out a coefficient that's the same between all of them. Okay, now we look at our middle term b, and we're going to go over here and do b divided by 2 squared. So 4 divided by 2 squared, 4 divided by 2 is 2, 2 squared is 4. So that means that I'm going to put plus 4 on both sides of my equation. Wait, that's not exactly true, right? We got to balance this equation. So if I just put plus 4 over here, technically I didn't just add 4 to the left side. I did 3 times 4 over here. Because I have that factor on the outside, I cannot simply just add 4. I have to think about what did I just factor out of everything, do 3 times that number. So I'm actually going to add 12 to the right-hand side. We're technically adding 12 to the left-hand side as well, but we have them separated. We have a 4 in this spot, but we multiplied it by 3 to get there. So we are going to add 12 to that side, to the right side. The next thing I want to do is simplify, is factor down this inside the parentheses. So we're going to have 3, and that's going to be x plus or minus something squared. What is x squared plus 4x plus 4 factored out to be? X plus 2 squared. That's still equal to 12. Normally here we would start getting x by itself, but I actually don't want to do that. We're going to do something a little counterintuitive. I want to minus that 12 from both sides so that everything is on the left-hand side so that it looks like my vertex form. So it's going to be 3 times x plus 2 squared minus 12. You can either set that equal to 0, you can set it equal to y, you can set it equal to f of x, you can just leave it without it equal to anything, I don't care, whatever makes you happy, because at the end of the day, I'm finally in vertex form and that's all I care about. Okay, if this is vertex form, what's my vertex? -2, -12. What's my axis of symmetry? -2, x equals -2. And am I going up or down? The last step is the same as what we were doing before. We just have to do a little bit of work to get it into this stage that I'm allowed to easily read. Because the 3 is positive. So it's just a facing upward. Good point. I'm not going up. I'm technically going down to 12, but it's facing upwards. Yep. Okay. We're gonna go do this on the other ones. I think A is the next easiest one. So let's pop up to the letter A. When I jump up to letter A, I first need to set this equal to 0, and I need to move that 3 to the other side. So before I do anything, I'm going to add 3 to both sides. So I get -2x squared plus 4x plus blank equals 3 plus a blank. Next thing I want to do is factor that common number out of my 2 terms on the left-hand side. So we'll take that -2 out. And we're going to be left with x squared. And when I divide 4x by -2, I get -2x, and then I get that blank. Everybody okay with what we're doing so far? Okay. Now, I'll do my b divided by 2 squared. -2 divided by 2 squared. -1 squared is 1. I'm going to add 1 into my parentheses, and I'm going to do -2 times that 1 to know that I add -2 to the other side. That's a really easy mistake to make. I messed up with that in my F period the other day, so. Yeah, Danny. Okay. Now I want to factor, so I'm gonna take that x squared minus 2x plus 1, and we're gonna factor down. I'm just gonna move over here so I get a little bit of space. So I've got -2 times something squared equals 1. -2x plus 1, that breaks down to x minus 1. Let me know if I'm moving too fast, or if you don't know, I just kind of a snoozy day, so I'm just gonna keep it moving. You guys good with that? Now, the last thing you want to do is move everything to the left-hand side so we can get it in vertex form. So we're gonna -1. So I get -2 x minus 1 squared minus 1. And that is in my vertex form. That is not at all right. Now that it's in vertex form, we're gonna write our vertex. What's my vertex here? 1, -1. What's my axis of symmetry? X equals 1. Up or down? Down direction. We've got one more like this, and then I'm actually gonna teach you a shortcut. It's gonna be fun in a second. One more like this. I do have a fraction out front, which usually stresses us out, but let's just treat it like we've treated everything else. So let's set this equal to 0, get the 1 to the other side. 1/2 x squared minus 6x plus blank equals -1 plus blank. I do need to factor that left-hand side, so I am gonna take a 1/2 out of everything, so I just get x squared. The one thing I want you to think about, and I'm just gonna do something off to the side, don't feel like you have to write it down. But when I did 1/2 divided by 1/2, that equals 1. Now I'm gonna do -6 divided by 1/2. -6 divided by 1/2, that's a little uglier than something divided by itself. Remember that when you divide it by 1/2, it's the same thing as multiplying by 2. So -6 divided by 1/2 is actually -12. So inside the parentheses, I'm gonna write x squared minus 12x plus blank. That's a little counterintuitive because we think, oh, we're dividing, we're getting smaller. Well, we're dividing by 1/2. So that's the same thing as multiplying. From this stage, though, I think you can do the rest on your own. Are you guys okay with how I factored that 1/2 out? Okay, I'm gonna be quiet. I'm gonna do the rest of it on the board, but I want you to try it on your own. Do your b divided by 2 squared, factor it out, move everything to one side, identify your vertex and your axis of symmetry. Okay. So I'll show my work so you can check in with me, but I'll be quiet. I've got all my work for that one on the board, so check in if you need to. Questions on this? It's a good skill to know how to do. All right, jumping down, you ready to do the shortcut now that we did the long cut? Anybody have any questions on putting in vertex form? Or completing the square, especially on that last one? Everyone's good with that? Okay. Now, the shortcut says that we're using the axis of symmetry formula. I believe this is something that you learned in Algebra 2, but in case you forgot, the axis of symmetry formula is this tiny little formula, x equals negative b over 2a. If you take your equation that's in standard form and do negative b divided by 2a, that's going to get you your axis of symmetry. That's going to get you your x. In order to find the vertex, you're going to take that x and plug in to get your y. And then we'll still just look at that first value to decide what my direction, if it's up or down, is. So let's jump over here. We're going to start. Here's my A, my B, and my C. So to start with this equation, we'll do x equals negative 16, which is my negative b, divided by 2 times a. Remember, a is negative 4, so we're going to do 2 times negative 4. So negative 16 over negative 8, x is going to equal 2. So without knowing anything else, that's my axis of symmetry. I use my axis of symmetry formula. X equals 2 is my axis of symmetry. We're going to take that and we're going to plug it back into my equation to figure out what the y value of that vertex is. So I'm going to plug 2 into my equation. That's going to tell me my y value. So I'll have a full vertex. Now, don't forget that we have to do our square before we do our multiply. That's a little PEMDAS thing that sometimes we forget because we know so many other things. Square your 2 first. So I've got negative 4 times 4 plus 32 plus 3. That becomes 16, negative 16 plus 35. Then I minus 16. I think that's 29. Oh, 19. That's embarrassing. Okay, so that's my y value. So that means that my vertex here is 2, 19. Notice that I don't change my sign because it's already in my axis of symmetry form. It's already x equals, it's not x in a parenthesis. So since it's not x in the parentheses, you don't change your sign, you just keep it the same. My vertex is 2, 19. My axis of symmetry is 2. And then I go look at that first number. And that says negative 4. So that means my direction is down. All right. Do you think you can try the next one on your own? It's a little bit of fraction work, but I bet you can do it. A little bit of fraction work at the beginning, but I ended up getting that my x was 9, and then I plug it back in and I solved to get my y was negative 26. Yeah.
Just another direction.
Looking at that a value, that value up front. If it's positive, it's just going up. If it's negative, it's going down. Good question. All right, I really just have one more thing I want to teach you. So go ahead and flip your paper over when you're done with this one, because I think that was it on that side, yes. The last thing I'm going to teach you is it says, write the equation of a quadratic function given a vertex and a point. So we're doing something similar. We're still using vertex form, but we're not completing the square. I think this is easier than what we've been doing, but it might not be something that you've done before. So we're going to kind of go through it carefully. This is the last thing I want to teach you. For today, not ever, just for today. Okay, so again, remember that our vertex form was y equals, bless you, a times x minus h squared plus negative. The reason that that is helpful is that my vertex is given to me here. So that means that I can take this equation and we're going to plug pieces into it. The one variable that we are not going to know that we're going to solve for is your a. So the a is what we are going to be looking for. We know our vertex is h and k. And then we are going to use the other point that it contains, and we're going to plug that in for x and y. Therefore, every variable now is accounted for except for a, which will just tell us if there's a stretch or a shrink or a flip. So we're going to plug those pieces in. We're going to solve for a. And then we're going to finish the whole equation by using our vertex, our newfound a, and plugging it back into vertex form. Okay. Well, let's start one step at a time. Let's start by plugging all of our pieces in. So I'm going to plug my h and my k in and my x and my y. Plus. Maybe let me be a little bit more intentional about these colors. So let me make this x and y. Okay, so I'll start by saying 5 for y. Y is equal to a. We don't know what that is. X, which is your 1, minus h, which is 2, squared, plus k, which is negative 3. Oh, yes, look. I flip the sign by just putting it in with a negative.
Okay.
Yeah. If it was negative, then I would flip that to a plus. And if you can kind of tell, I was a little dramatic. So I've got a plus, a negative 3, which is maybe too much for you. You're welcome to just cancel that plus sign out and just keep it a negative, or you can keep it a plus and just keep that dramatic. Okay. Now I'm going to start simplifying. I'm going to start by doing the inside the parentheses. So I'm going to do that 1 minus 2. So I've got 5 equals a times negative 1 squared minus 3. At this step, I like to add that k or subtract that k to the other side. So I'm going to move that 3 over here. And at the same time, I can do my negative 1 squared. So I'm going to get my constant to the other side. So now I've got 8 equals negative 1 squared is 1. So 1a is just going to be 8 equals a. The reason I do that is if you don't add that 3 over, sometimes what you do, don't write this step down, I'll fix it in a second. Sometimes what you guys do is you got 5 equals a times 1 minus 3, and then you do that 1 minus 3 together, so then you got 5 equals negative 2a, and then you divide and then it's all wrong. So I get rid of that 3 almost immediately so that I can't mess myself up. So I added that 3 to both sides. Okay. Now I'm done. I have my a and I have my vertex. So I'm going to go plug those into my vertex form. This time when I say write the equation, that means please leave x and y in as variables. Don't plug numbers in for x and y. So we'll say y equals 8 times x minus 2 squared minus 3. That is my equation of that example. That's my vertex. That's the point it contains. It's stretching by a factor of 8. So that is my point. A lot of times I see a mistake where we forget our square either in the final equation or in our problem. So please, please, please do not forget your square. Okay. We've got 2 more like that. You want me to walk through another one with you?
Yes.
Okay, I'll walk through another one with you. If you feel good, you keep moving without me. So again, I'm going to label my vertex as h and k. I'm going to label the point that it contains as x and y. And I'm going to go use my vertex form equation. I'll say y equals a times x minus h squared plus k. So my y goes first, it goes -2 equals a times 0 minus 9 on h 5 squared plus 1, which is k. Again, I'm just being dramatic with the colors, but that might be helpful to you to know what goes where. Anybody questions on the plugin so far? All right, start simplifying. I like to do that parentheses first. Now actually is not a bad time to minus that 1 either from both sides. So you can minus that 1 whenever it makes you happy. I want to do it before I forget about it. So I've got -3 equals a times -5 squared. So I'll square that -5, so I get -3 equals 25a. And then this is kind of a common mistake I see you guys make. When I'm getting that a by itself, you're dividing that coefficient off. I'm dividing by 25 on both sides. Every so often, you guys have your fractions flipped. So sometimes if I'm not sure, I physically write divide by 25 on both sides. So I get -3 over 25 equals a. These are gonna be funny numbers. So if you get something really weird and funky, like normally I would see -3 over 25 and be like, what the heck is that? Let it be. It's gonna be a little funky and it's gonna be okay. So then that means y is equal to -3 over 25, x minus 5 squared plus 1.
With +1 or -1?
Plus 1, I think. Because the k stays the same. Right? All right, last one. Let's do it. I'll be quiet this time. I'll do my dramatic colors on the board, but I want you to try letter C on your own. I think I did that right. Does that look good to you guys? It's really easy to plug the wrong point in. I know in F period the other day, I plugged the point it contains in instead to make sure that you're using the vertex, not just the other point. It's a very small thing, but it's an easy mistake to make. That's all I really want to do today. Does anybody have any questions? Okay. I'm going to turn off the video then.